like to welcome everybody here today from some of my students, some people that are from classes at Ketcham, and Mr. Davis and Mr. Friedman. And I'm kind of excited about this going on today. So just to talk about our guest speaker, we are going to be talking about the moon. When I was talking to him last week about coming and joining us, he was talking about how we're going to the Lake of Death. I said, well, that's kind of cool. And it is, we're going to be talking about NASA going back to the moon, but they're going to be, astrobotics is something you wouldn't most likely have heard of, but we're starting to see commercialization coming into our space program, and they're going to be making the lander that's going to be going up that we'll be hearing about. So we're really kind of in the middle of an exciting week with space. It's kind of quietly going out there. I've seen it in the news, but we're basically in the middle of 3 spacecraft getting to Mars in the same week, essentially. I guess an 8 or 9 day period. The Hope mission got there to Mars on February 9th, and what's exciting about this trio is we're seeing different countries. The United Arab Emirates, it wouldn't be the first country to come to mind with a space program. But there they are. So that's nice to see. Chinese first mission to Mars is arrived on the 10th. They do have a landing in there somewhere, but they haven't done that yet. And then tomorrow, we're going to have the Perseverance is going to be landing on. We'll let somebody in, and so it's. I know that's all Mars related, but we'll take another 4-letter space object that starts with M and talk. So we have. We have Dr. I'm saying doctor, but he says just call him Michael. Michael Purucker is here with us, and I'm calling him an Astro Geologist. But if you heard that before, he has lots of titles. He works for NASA, and and a lot of these sciences blend together. So I'm kind of excited. And he got his bachelor's and master's from the California Institute of Technology, Caltech, and got his doctorate in geology at Princeton. So that's pretty impressive. So does he have time for anything else? Well, that I don't know. Oh, wait a minute.
There we are.
Okay, so I happen to, even though I am a science teacher and he is a scientist, we happen to meet for another reason that we both kind of enjoy cycling as a hobby, and that's his son there. I was biking to the eclipse in 2017, happened to ride with his son, and Michael came up in Fayetteville, West Virginia, where we managed to find an escape room. So we had escaped from a room less than 6 hours after I met you. Scientists are real people too. And so welcome, Michael, and I will let you take it from here.
Okay, thank you, Tad. I'm happy to be here, and T-1 from Mars 2020. We're very excited about that. We'll certainly be watching that, and we actually have colleagues who have contributed to that mission, Mars 2020. We have actually also have colleagues who have contributed to the UAE mission, and so that's also very exciting. But I will focus on a few other things now. Basically, NASA's Back to the Moon effort. We actually haven't landed on the moon since the Apollo days, and so NASA put out a call for proposals about 1.5 years ago, and said they wanted to do this with a commercial vendor, and so Astrobotics responded, and so we're going to be putting our instrument on the Astrobotics lander in Pittsburgh. We'll be going there this spring to do that for preparation for a launch in the fall. So I'm going to present Okay, and can you see that? Space exploration at NASA?
That looks good, thank you.
All right, excellent. So one of the things I want to talk about, of course, is NASA's role in space exploration and the commercialization of space and some NASA science with which I'm involved. And then I will talk a little bit about the possibility of your students working or interning at NASA. So I think that should get us through just a few minutes here. And then we have to hopefully have some time for some questions here. Okay, and I'm Michael Purucker, just call me Mike. And I've been at NASA Goddard Space Flight Center since about 1986 as a scientist, and initially for the first 25 years or so, I was what we call a soft money scientist. I worked on missions, I worked on contracts, but I was not a NASA civil servant. I was not a government employee. I was an employee of a contractor and several of those contractors. And I got my PhD in geoscience from Princeton, and many of my advisors, not all of them, but many of them were involved in the space program. For example, I had one of my advisors, who was one of my primary advisors, was involved, with NASA, looking at impact, the records of impact in basically in South Africa and other places, and my advisor at Caltech was Gene Shoemaker, and he had always wanted to go to the moon, but he settled for teaching astronauts the rudiments of geology, the Apollo astronauts, and so he was very much involved in that. And so when I first knew him back in 1971, I had to find an elective science course, and so I elected this geology, introduction to geology or geoscience course that he taught. And so he was a very inspiring teacher, and so that really sealed my fate in terms of the actual area that I was going to do in science. I had planned to be a scientist. Going to Caltech, you're not going to do much of anything else. But this convinced me to work in the area of magnetism and space exploration. So that's what I've been doing since the 1970s and 1980s. Initially, when I first got my PhD, I worked in Saudi Arabia doing oil exploration as part of a package that the Saudis worked with the U.S. Geological Survey to interpret aeromagnetic surveys of a part of Saudi Arabia that had not been explored for oil and gas yet. So we helped them find some, and so magnetics is part of that toolkit, and I'll explain some of that. But I hope you all will watch the Perseverance land here. And one of the things I was talking about with Tad before was that it's a challenging time to work at NASA because we have this problem, of course, of COVID, and basically I'm at home, and the only people who are in our labs right now are our engineers who build our instruments. And they're basically, so we have a fairly large lab. It's about the size of a large room in your house, for example. And so we build these instruments, these magnetometers, which measure magnetic fields for space in this lab. But we can only have one engineer or technician assembling these magnetometers at a time. So obviously it slows down the process of building instruments. And one of the reasons I like NASA is because you can be involved in missions, and you can be involved in designing missions, proposing missions, implementing missions, and studying the data from the missions, and doing science. And so it offers a lot of opportunities. And of course, today is a special day too, because it's Ash Wednesday. This is a holiday. This begins what we call the Lent cycle. So this is 40 days before Easter now. And so it comes to mind because, of course, one of the things that that the commercial provider for this this lunar mission is going to do, they are going to take mementos to the moon, and they will probably take ashes to the moon, ashes of recently deceased individuals, and that's part of the commercial package. They actually work this a little differently. So you don't actually contract with Astrobotics to have your ashes shipped to the moon, to the Lake of Death, but you actually contract with one of their secondary provider, and I suspect that's because there are some issues. Several, there are cultures. For example, the American Indians, Navajos, basically think the moon is a sacred place, and they don't want human remains there, basically. And so when my advisor, Gene Shoemaker, died back in the 1990s, several of his colleagues asked that some of his ashes be put on a mission to the moon that was going to orbit the moon. It was called Lunar Prospector, and NASA agreed to that. And so at the end of that mission in 1999, when the spacecraft was about 15 kilometers above the moon and it was finished with its primary mission, it was commanded to impact into the south pole of the moon. And so my advisor's ashes, some of his ashes, are at the south pole of the moon. So he in a sense, got his wish to go into space. Just a little later than normal. Okay, so NASA is not the only name in space exploration. NASA and ESA and basically the Chinese Space Agency are the big three. And I have worked with NASA and ESA, and I was basically seconded to ESA between 2000 and 2010 to work on a mission that's now in its 7 years old, and it's been up 7 years mapping the Earth's magnetic field. And so that mission is called SWARM. It's 3 satellites in a very low orbit. And so NASA and NASA shares this terrain with a lot of other countries. This role in space exploration, and in fact, all of the European nations, even Luxembourg has a space agency. I've worked with several of these, and especially the German Space Agency and the French Space Agency. I was a contractor then, and so it was easier for me to travel. And I worked in French and German universities in teaching for some students who were involved in these projects. So NASA has obviously a role in space exploration, but not the only role. There is also a strong commercial sector that is getting larger. All of us know about SpaceX, and I think Tad said that he has a student there who did an internship at SpaceX. Actually, the commercialization, the first commercial satellite that NASA was involved with were weather satellites, and so that was the first thing that was being commercialized. And so at this point, of course, just about everything in that can be commercialized is now, and so basically what is happening with Astrobotics is NASA put out a request for a company, a commercial entity, to fly a number of payloads from NASA, 11 or so, to the surface of the moon, and the company had to make a bid and proposal and to say when they would do it and who they would launch with. So they had to identify the launch provider, the rocket, for example, like a SpaceX, and they had to identify the time when they would get there. And so SpaceX won this. Astrobotics from Pittsburgh won this competition. about a year and a half ago, and then NASA put out a request for proposals for very mature instruments that would go on this spacecraft, this lander. And so I responded, and we are now, in the process of completing the, basically just completing the calibration. The actual hardware is all done. We're just now calibrating the magnetometer in the lab. So let's see. I'm going to go to the next slide. Okay, can you see this? Can you see the cartoon I have here?
Yes.
Tad?
Yes, I can see it.
Okay, good. All right. So one of I love cartoons. I had my first boss at NASA was a wonderful cartoonist, and he always peppered his emails to us with cartoons. And so Gay M. Wilson is also a very famous cartoonist. Just died in 2019, and he has two of my favorite lunar cartoons. On the left, of course, it says, "Only a minute or so, and man will have his first view of the other side of the moon." So there's a moon, there's a shell that is basically pointed towards the Earth, and it says Act 2, Scene 4. And so this is actually realistic in the sense that we know that the moon always faces us with the same face. And so, it's just, part of it is bright and part of it is not. So we really didn't actually know anything about the far side of the moon until, rockets went there. And so this is perhaps might be a realistic rendition of what you might imagine there. So the moon is in a resonance, and so that's why it stays in this, always facing, the front side of the moon. And of course, the other cartoon is a little more somber, and it says, with a burned out moon up there. But then it turned out there weren't any weapons of mass destruction on the moon after all, WMDs for short. So yeah, this is space is it's a frontier for a lot of things, for exploration, but it's also a frontier for the military. And we had within the past 4 years the Space Force, this new branch of the military which is going to be designed for space. So these are exciting times. All right, so here's another sort of cartoon that I have been helping to put together and to iterate on, and what this shows is in the planets and the moons of the solar system, what the area is. This is an equal area projection of the solar system, showing all the solid surfaces in the solar system. So it doesn't show the large, Jupiter and Saturn and Uranus and Neptune don't have solid surfaces. They're balls of gas and ice, and so they're not included in here. So these are just the places where you could land a spacecraft, for example. And as I say, this is it's an equal area projection, but the boundaries really don't. They're really not of importance. It's just the area that's of importance, that the equal area. And so, for example, the largest area, the two largest planets that have solid surfaces are the Earth and Venus. And Venus, of course, is buried beneath clouds, and so its surface is at 600 degrees, 600 or 700 degrees Fahrenheit, and it's very hot and very and we've only successfully landed on Venus, I believe, twice, and it was not the U.S., it was the Russians, and the U.S. has never landed on Venus, nor has any other country. Mars is the favorite place, and of course it's shown there in the middle, the bottom of the center. And this is the size. And so I have added, and of course you see the Earth, and that's easy to navigate because of course we put the continental outlines on there. But one of the interesting things that I like to think about is about impact craters, because impact craters, basically the impact of a large meteorite on this planet or moon leaves a very distinct scar. And these scars can have magnetic signatures. So, and they, they inform us about the age of the surface. So they're very critical. So what I have shown here in red are basically the largest craters on each of these bodies that we know about. And the largest craters basically are on Mars. And that's because the surface of Mars is generally about between 3 to 4 billion years old, the surface. And there are only a few places on the Earth that have rocks that are that old. One of them is in southern Africa, and it's in a place called Fredefort. That Fredefort was the site of an impact about 3.5 billion years ago in what's called the Archean or early Proterozoic time, and it's a very beautiful area of South Africa. It looks like the Southwest California, but South Africa gets a lot of its mineral resources and its rich mineral resources, platinum, gold, for example, out of this because these were concentrated by this impact. And so this Fredefort crater is the largest impact crater that we know about on the Earth. And so you would think that the largest impact craters on these planets, because this is an equal area projection, should be about the same size. But it really reflects on the age of the terrain, of course. And so we only have maybe 10 to 15% of the Earth that is of the continents, of course, that are of the appropriate age. And these impacts basically they get smaller when we get closer to the present. Basically, in the early days, 4 billion years ago, there were a lot of big rocks bouncing around the solar system, and they impacted planets. And so then there was a smaller population of these things. So this is something that I'm interested in because it basically gives you information about the age of the surface. And magnetics can inform that too. So what I do, my small piece of NASA science is basically focusing on the magnetic fields of the planets and moons of the solar system. And the group that I lead at NASA has built a lot of these magnetometers, more than 83 now for 48 missions. We've been doing this since the 1960s. We provided the magnetometers for both the Voyager 1 and Voyager 2 spacecraft, which basically did a grand tour of the solar system. And they're still working. They are powered by nuclear energy and the decay of plutonium. So it's a heat source. So we have been to all the planets in the solar system with our magnetometers to measure these magnetic fields. And basically what you're going to see in some of the figures I'm going to show you are maps of the magnetic fields, of various aspects of the magnetic field. And this is one of my mentors at NASA who built many of the magnetometers, built the Voyager 1 and 2 magnetometers, built one of the Mars magnetometers. This is Mario Acuna. Mario was from Argentina, and he came to the U.S. In the late 1950s, and eventually got his PhD at Catholic University. And that he is showing us a picture. He is showing us one of the magnetometers that he's built. And I'm not sure which one where it went to, but it's obviously a good sized magnetometer. So that's just the head of the magnetometer, the sensing element that senses the magnetic field. All right, so this is the latest lunar magnetometer that Tad saw on my Facebook page, and that's how he got in touch with me. This is going to the moon in the fall, and so I don't have a scale on here, but it's about 10 inches by 5 inches by 5 inches or something like that. So it's less than a foot in the long dimension here. Yeah, pardon me if I go back and forth between metric and imperial units. We shouldn't do that, but we do anyway. And so this basically is going to go on the upper deck of the lander, and at when this hopefully successfully lands in the fall, the magnetometer, the sensing element, which is in the top left-hand corner there, will pop out with this boom. So it will be deployed at landing so that it can be, go as far from the spacecraft as possible, because of course the spacecraft it has magnetic parts, and so we don't want to see them. So one of the things we're going to do is, over the course of a lunar day, is to map the magnetic field in the area that we're landed in, the Lake of Death, and then at some point we will actually stop, because it's not designed to last through a lunar night. So that's the. So here's another example about how small these instruments are. They're generally less than a kilogram. They use just a watt or so of power. So this is the Astrobotics page, the web page. You can see they have this commercial lunar payload services. It's called the CLIPS program, and so they're going to deliver a suite, one of our magnetometers, to the lunar surface. So we will do some science, and of course, down immediately below that is their mementos to the moon, the DHL moon box, if you want some keepsakes. And that, if you actually bore down here, you'll see that they ask the question, can you send your ashes? And they say no, but somebody, there's a company that we work with that can do it, and it'll go on the lander. So I think this is just their way of not being bombarded all the time with requests for ashes. But in any case, you can't send any more ashes because they closed January 15th. So that's gone. But you can think about that for the future if you want to go to the moon. So I'll give you a few minutes. Tad, how much time will I run through here?
We're running close to the end.
Okay, good. Now I'll summarize 5 minutes, and then we'll take some questions. Okay.
Okay.
Okay. So
might have other things scheduled. So I was asking. I was asking for them to be here for the 33-minute class time, which is.
Okay.
So very good.
Okay, so basically, magnetics allows you to understand the structural geology, and it contributes to oil and gas and mineral exploration and geologic mapping. So it's a very useful tool for the surface of the Earth and other bodies. And for example, here is a summary of what we have learned at Earth, Mars, Moon, and Mercury about their tectonics and the impact and igneous rocks and the solar wind and the basin development. And all of these potentially have magnetic signatures. And so this is just the general summary of it. And here's a map of the magnetic field of the Earth, of the crust. And so what you see to firsthand are the continents with a very strong magnetic field, which is basically blue or in or purple. And the oceans are much weaker, much less magnetic, because they have a much thinner shell, a much thinner crust. It's basically a difference between 40 kilometers and 5 kilometers. So that's a substantial difference. So here's what impact does. That's that picture I showed you. On the right, I was talking about the Friedefort magnetic Friedefort impact from from 3 or 4 billion years ago, and this is the magnetic signature of that. And there are magnetic signatures on Mars, basically associated with places that where Mars had a dynamo. And at the moon too, there is they're called Nectarian age craters. The moon also had a permanent magnetic field 3 or 4 billion years ago, and so there is evidence of that being preserved. Well, you know, one of the big things that you probably have heard about is the extinction of the dinosaurs, and of course that's preserved. The impactor that killed the dinosaurs as a consequence of probably acid rain or basically a nuclear winter is what it amounted to. This is preserved beneath the or basically right on the boundary of the Yucatan Peninsula. And it was recognized by its gravity and magnetic signature. And you can see it right there in Merida. Merida is the closest city. So some of you who have been to Cancun could have gone to see this. And let's see, here are just a couple of pictures of the moon. This is the South Pole Aitken Basin on the far side of the moon. This is the largest impact crater on the moon. And you can see the blue indicates low elevation. And here's a magnetic map that I put together that shows dikes intruding into this area after presumably the impact hit. And here's a map, global map of the moon. And here's a map of Mars. And Mars basically has a much stronger magnetic field, crustal magnetic field, than the Earth. It's almost an order of magnitude higher than the Earth. And so we really don't understand the mineralogy or what the rocks are, but we know that all of these these intense magnetic fields are in the oldest part of the planet. So that's a clue. And here is a map of the global Martian magnetic fields, and they also record faulting. Valles Marineris is the largest, basically tectonic valley on the planets, and so it's there are several hundred kilometers of offset that can be documented magnetically. And we always, continue to think about new missions at Mars and the Earth, and we think about solar-powered aircraft. And of course, you probably know that the new Mars Perseverance rover will also bring out a little helicopter that's going to try to ascend there. That's interesting to see. So working at NASA, here are all of our centers, and I also show the intern.nasa.gov. We have high school to graduate level internships and fellowships, and you can find the information there. And I am at GSFC, Goddard Space Flight Center, and you can see we have the largest group of scientists and engineers of any of the NASA centers. So come on and visit us, okay? And thanks for having me, Tad. And questions?
Okay, thank you very much. I'm sure there's a round of applause that's being unmuted in there somewhere. And there we go.
Do you want me to stop sharing, or do you want to wait yet?
You can stop. Yeah. You can
okay.
Stop. So we still have 49 people here. So very good for staying with us. And now's your chance if you have any questions. I did ask my students to generate questions, but I would like to give you the opportunity to ask it yourself, so you can unmute and ask the questions, or you can type it in the chat. So hopefully there's something in there.
I have a question.
Yes.
Yes, Tristan, thank you.
How fast is the internet at NASA?
How fast is the internet at NASA? Well, of course, we want to be secure, and so it's a little it's a little slower because we all have to use VPN. And of course, I'm not making this presentation from NASA at Goddard. I'm making this from my home office. And in general, I have only been to NASA 3 or 4 times during the pandemic. And so it's only my engineers that go in. But yes, we have very fast communications networks at NASA.
Anybody else, please?
I see a question. Why do you think people wanted to send their ashes to the moon? Well, I can only tell you a story about my advisor. Of course, he wanted to go to the moon as an astronaut back in 1962 when they offered the possibility of for the first or the second class of astronauts. But it turned out he had a very strange condition that prevented him from going. It was basically a condition of his pituitary, and he ended up in the hospital for several months before they were able to diagnose it. But in any case, it made him ineligible to go to the moon. But of course, he could train the astronauts to go to the moon and recognize features of interest. And then, when he died, his wife and many of his students were very excited to, because we knew he wanted to go there. So we made it happen. So, let's see, what large developments do you foresee in space exploration within the next decade? Okay. I would say that what we're going to see are more countries getting in the space race, and as I mentioned, all of the Europeans have a space agency. Even small Luxembourg has one. So you're going to see more countries get in the game of space exploration, and you're going to see more contractors and commercial efforts in this game too. So that's my prediction. Do you think they'll try to make a moon base? Well, so I was going to talk about how do you get how would you what would you if you got to the moon, you would actually have to you wouldn't want to be outside for a long time. You'd probably want to bury into the soil a little bit, and just a meter of rock or dirt above your head would provide adequate protection from radiation for the sun, for example. And this would be a problem for Mars too, but less so. Yes, I think they'll try to make a moon base. And the nice thing about the moon is that it's a nice stepping stone to go to Mars if we wanted to send humans to Mars. So I think I've answered the 3 questions that are up there. Any others?
Okay, last chance for, oh, wait, there goes another one.
All right, so does the strength of the magnetic field of a planet determine the strength of the magnetosphere? You said that Mars has a stronger magnetic field than the Earth, but doesn't Mars have a weaker magnetosphere than the Earth? Good question, excellent. So yes, the strength of the magnetic field of a planet determines the strength of the magnetosphere. That's right. Mars used to have a global magnetic field 3 to 4 billion years ago, but that magnetic field disappeared, probably because Mars is much smaller than the Earth, and it cools faster as a consequence. And so basically, whether a planet has a magnetic field is a strong function of its size. For example, Jupiter has the largest global magnetic field of the solar system, and it also has the largest magnetosphere in the solar system. So the magnetosphere is that part of the planet, or that part outside of the planet that basically is connected to the planet's magnetic field. So it's bounded by the sun's magnetic field. The sun also has a magnetic field, and it basically shoots out in a spiral. If you would look down at it from above, and in these spirals, you would see a lot of nuts, if you will. These are the magnetospheres that are carved out of the solar wind. So that's a good question.
So Mars indicates a stronger magnetic field because the rocks are older and it's preserving that magnetic field from back 3 billion years ago.
That's right. That's right. So the magnetic fields that are preserved at Mars are preserved in the crust of the planet, not in the core.
And because our planet has plate tectonics, it's recycled a lot of that early indications.
That's right.
Okay.
That's right.
You got
So next question is, how far in the future would you think people would land on Mars?
oh boy.
Well, so, we haven't even decided yet when we're going back to the moon. Maybe it's going to be 2024, but I guess it's going to be later. Humans are a very fragile species in terms of space travel, and it's very difficult to protect them sufficiently to get a long ways. I mean, a trip to Mars, as we just have seen, takes about 9 months with a standard chemical propulsion. And that leaves a lot of time for space weather to impact the astronauts. And so that space weather, the solar wind is we are protected here at the surface of the Earth. But if we were outside of the Earth's magnetosphere, we would not be protected at all. So it's going to be quite a while, I would say. I would say, maybe 20 years. All right. What are the commercial prospects in space beyond trips to the outer reaches of the atmosphere and joint programs with government space agencies? So that's beyond trips to the outer reaches. That's space tourism, I guess, is what you want. And joint programs with government space agencies. So there, as you may know, there was also a prize that Google offered. It was called the Lunar Google X Prize for the first commercial program for the first lander to land on the moon, not sponsored by a government agency. And so this was a competition. A lot of people worked on it, and the front runner was a group in Israel that formed a company, and they put together a spacecraft, but they didn't make it in time. They weren't able to launch it until I think 4 years ago, and unfortunately it crashed. It didn't make it to the surface.
You did skip one question. I think we'll finish with that because 30.
How much training does it take? Yes, okay. It does. It does. It takes several years to train to be an astronaut. Generally they don't allow you to be an astronaut if you're older than 40 or 50 years old. But of course, we had these senators going up in their 50s or 60s or 70s. So John Glenn went up again. Jake Garn went up.
One of the 12 people that walked on the moon was only one was a scientist. Is that correct?
Right. So Harrison Schmidt was a scientist. And he was a student of Gene Shoemaker's, and he was also a geologist for the U.S. Geological Survey. Harrison's still around. I see him. Well, if I were at NASA, I'd see him yearly or so. So after NASA, he became the U.S. Senator to New Mexico, but I think that was only for one term.
Okay, I think that should do. We're 45 minutes in. Michael, thank you very much for stopping by.
Thank you, Tad.
And
good to meet you guys.
All right. So thank you very much, and enjoy your day.
All right.
Let's go for a bike ride somewhere.
I hope so. Well, thank you very much, Tad.
All right.
Yes.
Thank you very much.
Take care.
Okay.
Bye.